Welcome. Today we're going to learn something or review something that's going to be super helpful and make us be way more efficient when we're dealing with exponentials. We've been solving exponentials by graphing them on our calculator and finding where they intersect. There's an algebraic way to do that as well that can be a big time saver for us, and that's by using logarithms. Just like when you're solving an equation that has multiplication, you use the inverse operation, division, to solve that. Exponentials have an inverse operation as well. They're called logarithms. And a logarithm can be converted to an exponential, or an exponential can be converted to a logarithm. This is what the logarithm looks like. It's read log base b of x is y. It's the same thing. This particular logarithm is the same thing as this exponential. This is an exponential because you have a variable up here as an exponent. Now, don't get caught up on the location of your x and your y. We're probably used to seeing y equals ab to the x, and the x was the exponent. Regardless, it has a variable as an exponent. Let's look at how the two compare. When you look at this logarithm, it's a log base b. Well, right here in the exponential, the base of the exponential is also b. Of x is equal to y. Y is the exponent that you're wanting. A logarithm is really just the exponent that you need to raise this b, the base, to. So this base needs to be raised to this power to equal that number. See how that works? B to the y equals x, b to the y equals x. We kind of do this loop thing in there. What that allows you to do, if you can see, the y is caught up as the exponent here, but if you convert it to a logarithm, the y is all by itself. So we'll be doing that. Today we're really practicing just understanding how to evaluate a log, how to switch between a log and an exponential. We're not going to do a lot of solving today, but today what we want to do is master and get fast at just evaluating logs. That's our goal. Let's start with just some very basic logarithms that you can evaluate. You should not need a calculator for these. Recall that a logarithm is just the exponent that you need to raise the base to. If you look at this first one, 7 needs to be raised to what power to get you a 49? Well, it's just a 2. So log base 7 of 49 is just 2. 2 needs to be raised to what power to get 8? Here's a trickier one. 5 needs to be raised to what power to get a square root of 5? A square root is really a 1/2 power. So log base 5 of the square root of 5 is really equal to 1/2. Here's another weird one. 7 to what power gets you a 1? Well, think about it for a second. 7 to the 0 power? Isn't anything to the 0 power equal to 1? So that could be log base 8, log base 9, log base 3000, anything. If you're taking the log of 1, it's going to equal 0. All right, let's try this last one. It's another weird one because you have this decimal. What you'd want to do here is really look at this differently. And instead of thinking of it as a decimal, think of it as a fraction. And then say 4 to what power gets you a 1/4? Well, what forces that 4 to go to the denominator? It's a negative exponent, so it's going to be a negative 1. Okay, quiz time. I've got a bunch of these. I want you to try to get through these as quickly as you can, but no cheating. You got to try it yourself. Don't sit there and wait for me to do them for you. Go evaluate these 9 logs, and then we want to get fast at this before we move on. No cheating. Pause the video. Let's quickly go through these. I'm going to go through them, but not necessarily in the same order that they are listed on your page. And some of these might be a little bit different than what are on your note sheet. We'll see how it goes. Let's pick out the easy ones first. 7 to some power is 49. We did that one earlier. 7 squared would be 49. How about this number 8? 10 to some power is 10,000. Think about it. If you had 10 squared, that'd be 100. 10 to the third is 1,000. So 10 to the fourth power is 10,000. So that would equal 4. Let's look at number 3. 8 to some power is 1. Recall that the log of 1, regardless of the base, is always going to be 0, which means this number 6 is also going to end up 0. Let's look at number 5. This one has the square root on it. 5 to what power is the square root of 5? Square roots are always 1/2 powers. But let's look at number 9 then. This one has a radical, but it's not a square root, it is a fourth root. If you take the fourth root of something, that's not going to be the 1/2 power, that's going to be the 1/4 power. Let's look at 4. 4 to some power is 1/16. To bump that 16 to the denominator, it had to be negative. But then I also wanted to change my base that was a 4 into a 16. Not only will it need to be negative, I will have to square it. 7 is very similar. It's going to have to be negative to bump it down. And 2 to what power is a 32? It's 2 to the 5th power. So -5 is that log. And the very last one, which is really probably the easiest one here, and yet is still probably the trickiest one for most students, is just because it looks weird. It has this exponent in it. But you're just saying 4 to some power is 4 to the 9th power. Let me write it. 4 to some power is equal to 4 to the 9th power. What is this power going to need to be? Well, it's going to need a match. It's going to have to be a 9. 4 to the 9th power is 4 to the 9th. All right, we're getting better, maybe, hopefully, but we're still going to practice to get good at this. We're going to go to Quizlet, and if we do this in class, we'll do Quizlet live. But if you're doing this on your own, I would very strongly encourage you to pause the video, but jot some stuff down here first. You're going to go to Quizlet.com. And in there, you're going to click the magnifying glass and search for Evaluate Logarithms. And it will pop up with a whole bunch of different study sets of flashcards. And if you scroll down a little bit, you're going to find probably my set of flashcards. You can do any of them, it doesn't matter. But if you scroll down, I have a set of about 20 there. And click on that set and do it like a flashcard. Now it may come up backwards, like where it gives you the answer. Well, it's not Jeopardy. We're not giving the answer and coming up with a question. That'd be kind of tricky. So you can click the button, I think it's in options, where you can switch whether they give you the term or whether they give you what they call the definition. Switch that so they're giving you the question, the logarithm, and then you guess the answer, flip the flashcard, and see if you're right. There's other games and stuff that you can do with it. I don't know how familiar you are with Quizlet, but it's a great study tool. I want you to go through that stack of flashcards 1 or 2 times, get really good, and then come back to this video. So pause it, minimize, go to Quizlet.com. The second part of the lesson today is going to be being able to switch between exponentials and logs. If we have an equation that is an exponential, we'll want to convert it to a logarithm so that we could then solve it. But it also works the other way. If we have a logarithm, we want to switch it to an exponential. whatever we got to do to be able to solve. So on this page, now again, remember that solving is tomorrow. We're not really going to solve. All I want to do is practice converting and understanding where the numbers go when you switch from a log to an exponential and vice versa. And I'm actually going to start with these logarithms because they're similar to the ones we were doing earlier where you do this loop thing. If you look at this logarithm right here, I've got this x caught up in the logarithm. I wish it was more of an exponential, so I would switch it. You got to take your base to this power equals x. 5 to the 9th power equals x. These are equivalent statements. This one is more helpful because I could just type 5 to the 9th in my calculator and know what x is. It's not so great here. Of course, I don't care what 5 to the 9th is right now. All I want you to do is practice switching the forms. Let's come to this next one. The base to this number equals 8, okay? X to the 2nd power equals 8. Last one, I want you to try this one on your own. Convert this one to an exponential. Do the loop. You should have 2 to the x power equals 10. Now, not only will we have to switch from logs to exponentials, we're going to go exponentials to logs. Let's go over on the left and look at this set of examples. These are already exponentials. We have to turn them into a log. The thing you want to remember is the base of your exponential, that's the number being taken to the power, that's your base, is the same as the base in the log. Those are always going to be the same. The other thing I always remember is that the logarithm is an exponent. So whatever this equals, it always equals your exponent. Equals 2, so that's your exponent. Equals x, that's your exponent. On this first example, I have a 64 equals x to the 4th. I'm going to write log. The base of this exponential, the number being raised to a power, is x. It'll be log base x. Of 64 equals my exponent. Let's try again. Next one, log. The base is 3, so log base 3 of 39 equals my exponent. You do the next one. Log, the base is 5, of x equals my exponent. All right, so now that we can switch forms, let's talk about some of the special logarithms that we're going to come across. One of them is called common log, and it is a log base 10. It's so common that we get lazy and we don't even write the base on the logarithm. If you just see a log 7, this is assumed to be common log. We assume there's a little 10 right there, though we don't write it. When you try to evaluate logs on your calculator, that's the button on your calculator that says log, that's common log, which means that we should be able to evaluate any of these logarithms using our calculator. If you do log of 100, well, let's try it in our head first. Remember that it's a base 10. It's like having a little 10 down here. 10 to what power is 100? Well, it should be a 2. 10 squared is 100. If you go to your calculator, you can test that. You can just press log 100 equals, and you'll get a 2. What do you think this one's going to be? 10 to what power is a 1? Well, it should still be a 0. Remember, that's that special one. But let's get something that's maybe not going to work perfectly. Now, I'm writing little 10s here to remind you, you don't want to get in the habit of doing that. You just need to recognize that it's a base 10. 10 to some power is 4,000. I don't think this is going to come out nice. I know that 10 squared is 100. And 10 to the 3rd is 1,000. And 10 to the 4th is 4,000. I'm sorry, no it's not. It's 10,000. I know then that the log of 4,000 is going to fall somewhere between a 3 and a 4. Let's try it on our calculator. If you do log 4,000, you get 3.6. Now, that should, well, I say it should be. It'd be awesome if it is not a big surprise to you, but we tend to have these linear minds and we think everything is very proportional and linear. When I looked at this and I said 10 to the third was 1,000 and 10 to the fourth is 10,000, since 4,000 is closer to 1,000, does it seem reasonable that your answer here would be closer to 3 than to 4? And yet it's not, because it's not linear. So keep that in mind. You got to think differently here. Don't always trust what we've done in the past and what instinct would tell you. The other special type of logarithm is called a natural log, and that's log base e. We talked the other day about e being the natural base that is approximately 2.718. And if we had a log that had that value for a base, it would look like this, but we don't really write log base e. We have a special notation. It's ln. And you can write that like I have on this font. I just wrote a lowercase ln, and that's fine. I typically write it with a cursive L, and I write it like natural log, like I'm writing in cursive. You can also write it with all caps, natural log. That's what it looks like on your calculator. I would discourage you from writing it like this, because as you're writing that just looks like one n. Probably looks like that on your note sheet. Looks like a 1n. It's kind of confusing. So try to use script or use caps. We do not write it like this. If you want it to be a base e, you write it as a natural log. Let's do some examples. E to some power is e to the 5th power. Well, that would have to be a 5. E to some power is 15. I don't know. Let's type it in. You just type your natural log button and then 15. And I have a 2.71. And you could do the same thing with the 64. You go ahead and give it a shot. What's the natural log of 64? Last one is a little bit different. Let's do natural log of a negative 6. And you should get an error. I just wanted to throw that one in there to remind you that we can't take logarithms of negative values. That's not going to happen. They're not going to try to trick you with that. Just be aware that that's not supposed to happen. All right, so I said we're going to solve equations tomorrow. True fact. We are going to do that tomorrow. We're going to do a little bit today. Just easy stuff. Let's look at these. I have right here this exponential where the x is caught up in that exponent. To get that x out of there, I got to switch it to a logarithm. This is going to be a log, and it's a base 10, so that would make it common log. I'm not going to write base 10. It's log of 14 equals my exponent. To determine what x is, I'm just going to use the log button on my calculator. What is the log of 14? And I have 1.15. Let's try the second one. This one's a logarithm. I need to switch this, because the x is caught in the logarithm, I need to switch this one to an exponential. There's not a base. I assume it's a 10. To the negative 4 equals x. 10 to the negative 4 equals x. By switching forms, I've isolated the x. I just need to evaluate 10 to the negative 4. I know the negative is going to bump it to the denominator. I've done it a few times now. 10 to the 4th is actually going to be 10,000. Let's try some of those with the e value. This one here, this next one is very similar to the one we had up here, only it's a base e instead of a base 10. When I switch this to a logarithm, instead of it being log base e, I'll write it natural log, and don't put the little base on it, natural log of 5.34 equals my exponent, which makes it really simple just to evaluate it in your calculator. And you get x to be 1.68. Last one, why don't you try this one on your own? This one's a logarithm, switch it to an exponential, and then solve. If you do the loop, looks like that. E, because it's a base E, to the 5th equals x. And you're typing that into your calculator. Remember from the other day that the e to a power is really second ln. E to the 5th power. I get 148.41. Just like we used Quizlet to help get us quick at evaluating logs, we're going to do this puzzle to help make all of this click, all the different things that we've done. You're going to get a puzzle that's 16 squares that are all jumbled up. You need to cut them out and put them back together in the right order. The squares are going to have different kinds of things on them. You might have something like, let's say, log base 9 of 81. If that's what you have, I'm looking for you to evaluate it. What is log base 9 of 81? And because you did Quizlet, you know, well, that's 2. So you would have to find a square, a puzzle piece that has a 2 and match those up. The other type of problem that you might see is an equation, and it might be a logarithmic equation or it might be an exponential equation. Perhaps it's something like e to the 7th equals x, let's just say. That's an e, sorry, I did a cursive e for some reason. Okay, e to the 7th equals x. I gotta erase it, sorry. If it has an equation, what I'm looking for you to do is find the puzzle piece that would be the equivalent, but only as a logarithm. So you take this equation and you switch it to a logarithmic equation. It would be a log, the base is e, oops, if it's a base e, it's not a log, it's actually a natural log of x equals your exponent. So the equation ones, you're looking to switch forms. If it doesn't have an equal sign in it, you're looking to just evaluate it. And ideally, the 16 pieces go back together in a nice 4x4 grid. You need to grab a partner and work on that puzzle together. When it's finished, have the teacher check it and turn it into the tray. Once it's done and turned in, then you can grab out your homework for this lesson. This is 3.3 on logarithms, and you can work on that. All right, good luck.